Hi, and welcome to Cloud on Air, live webinars from the Google Cloud. We're hosting webinars every Tuesday. My name is Deepti Srivastav, and I'll be talking about Cloud Spanner. You can ask me questions anytime on the platform, and we have Googlers on the standby that will take the questions, give them to me for me to answer. Today's webinar is kind of special because it's called Stump the Pros. Does Google Cloud Spanner go faster than the speed of light? And other FAQs. So your mission today, if you choose to accept it, is to ask me anything and see if I can answer them about Google Cloud Spanner. So let's get started. So to begin with, I just want to give a quick overview of Cloud Spanner, just to give you all a little bit of time to see what clever questions you can come up with. And we'll go into Q&A straight after that. So what is Cloud Spanner? So Cloud Spanner is GCP, Google Cloud Platform's enterprise-grade, globally distributed, and strongly consistent distributed database system. And it's built specifically for the cloud to combine the benefits of both relational database structure and non-relational horizontal scale. Now, what does that mean? So essentially, we've combined the relational semantics of schemas, asset transactions, and SQL, as well as the horizontal scale and availability of NoSQL systems into one fully managed and easy-to-use relational database service. What that means is you don't have to do any more trade-offs or tuning. So basically, you don't have to make the decision of, do I abandon relational semantics to get scale, or do I abandon scale to get the relational semantics because I can't actually do without sort of SQL and transactions across rows and tables. With Spanner, you get the best of both, so you can basically have high availability. We actually offer 99.999, 5 nines of availability SLA for our multi-region configurations, and all of this is packaged up into one easy-to-use system. So in terms of management, because we are a fully managed system, what that means is you don't have to have the burden and the overhead of constantly worrying about keeping your database up and running, right? In fact, it takes 4 clicks for you to even spin up a globally distributed database. You can go to our Cloud Console. You can just create an instance, create a database, create a schema, and you're good to go. So what that means is you don't have to worry about, oh my gosh, if I have to create an index, like, do I have to bring down the database? If I have to add a table, do I have to bring down the database? There isn't any management or maintenance windows that you have to worry about, because all of that is taken care of by us and our fantastic SRE team in the background. And you just worry about your database and getting the most out of it. Because we combine relational semantics with scale, what that means is that you get to launch apps faster, because you don't have to ever worry about learning a new language. We have ANSI SQL, 2011 compliant SQL. We have schemas, just like any other relational database that you're used to. We have sort of security and high availability built into the system. So you don't have to, there are not sort of nickel and dime add-ons that you have to pay for extra. They just come part of the package. All of that kind of gets offered to you so that you and your developers can create the best database that you want on top of our solution. All of this, by the way, is given to you with strong consistency. Cloud Spanner is always strongly consistent, right? There isn't any sort of which consistency do I need to choose to get the best out of my system, right? You always get strongly consistent data, which means you don't have to worry about it. You don't have to do cross-shard transactions, any of that. Because it's scalable, you get all of that built into the system, and you never have to worry about inconsistent, incorrect, inaccurate data, which means you can just build your application on top of your strongly consistent Cloud Spanner database, and you can just go, right? You never have to think about replatforming or really crazy bugs because of consistency semantics that are not met or not the way you expected them to be off your data, which means you're always getting consistent data and always able to create the best database, get the best database semantics on, and build the best applications as fast as you want, and you can just launch and go. So, as I said earlier, today's challenge is to ask me anything about Cloud Spanner, and let's have a discussion about distributed systems and how we made Cloud Spanner possible and available to all of you out there. Stay tuned for the live Q&A. We'll be back in less than a minute. Welcome back, and let's get started with our Q&A. So the first question we have is Cloud Spanner a drop-in replacement for other relational databases? So it is a relational database, Cloud Spanner is, but it's also horizontally scalable. What that means is you can use your schemas, especially for simple relational schemas, like it should be a complete transformation back into Cloud Spanner, right? We have DDL statements, we have joins, we have all that stuff. So it shouldn't be a problem to translate. However, and this is true if you've ever used a relational database, each database has its own quirks, and each database requires some massaging, especially for the more complicated data sets and the more complicated data types. So in general, I don't anticipate any problem with taking your relational database and moving it to Spanner. But there's always caveats on depending on the data set and the data type. The one interesting thing about Cloud Spanner is that because it offers what we call interleave statements, which is essentially a pre-join of your tables, it actually allows you to structure within a relational database hierarchical data sets. And you can actually pre-join two tables by putting interleave clauses in, so you can do fast scans. So you can think about it as, instead of having to do a join at every query time, for data that is queried together very often, you can actually interleave and join, predetermine the data set as join, and then Cloud Spanner can take that as a hint to quickly scan over a bunch of data. So hopefully that answered that. The next question we have is, how do you guarantee 4 nines and 5 nines of availability? That's a great question. So just to recap, Cloud Spanner offers 4 nines of availability for our regional instances and 5 nines for our multi-regional instances. So if you look at GCP zones itself by themselves offer 3 nines of availability per zone. And as you may know, Cloud Spanner is replicated within 3 zones for the regional instance and across 3 regions and at least 5 zones for the multi-region configurations. And multi-region configurations differ, so it could be all the way up to 9 zones. So the idea is, if you really look at the probabilities, even for the regional instance, if you sort of multiply out the probabilities for 99.99 across 3 zones, that's a lot of 9s. But we know that all failures aren't independent because, for example, within a region there is some geographic correlations, right? Like if a meteor strikes or something like that. So keeping that realistic, we offer the 4 nines for the regional, and in the multi-region case, because we have actually distributed the database across multiple regions, as I said, at least 3. That means we are taking care of not having geographic correlated faults. So in that case, we can remove one element of sort of risk, and we can offer you up to 5 nines. I hope that made sense. Our next question is, I read about interleaved tables. What's the advantage of that? So I think I mentioned that in the first question, actually. But basically, what the interleave statement in our DDL language is a hint to Spanner to say that you will query these two data sets very often together, right? So if you have let's say you have a table albums and another table singers, and because you're running, let's say, a music service, for each album, for each user, you have multiple albums and multiple singers, right? So you constantly query for a singer all their albums, which means you're gonna, in a traditional sense, you will have to do a join of singers and albums and then produce the results. In Spanner's case, if you say interleave albums in singers, what that means is that the system, Spanner itself, will pre-join the data set and store it such that when you actually query them together, it'll just do a fast scan, which means you avoid the penalty of. So our next question is, if I start with a single region, is it possible to scale to multi-region easily? So currently, the way we expect customers to do it is to take a export of their Cloud Spanner database and then import it into a multi-region configuration. We hope that in the future we'll have an easy solution for you to have this as a managed thing, so you can just sort of tell Spanner, hey, I want to move this database from this single region into a multi-region configuration, and you can specify both, and we should be able to do that, but that's not currently what we offer. So our next question is there a documented migration path from Cloud SQL to Cloud Spanner? So there isn't a documented path, but we do have customer use cases of how they've done it. So Quizlet, for example, is a online test study application, and they've actually migrated from their multiple, I can't say how many, but multiple Cloud SQL shards into one Cloud Spanner database, and they've written a case study on it that you can find online. It's linked from our docs, actually. So you can look at that. We have other such use cases and stories as well. Again, we hope to have solutions papers for customers to be able to do this, and they are coming shortly. But as of right now, you should be able to find information based on the customer case studies. Next, when would you choose Cloud Spanner over Cloud SQL? That's an interesting question. So there are obviously two use cases. One is if you've already been using Cloud SQL and you've had to go to the sharded solution for Cloud SQL because your data set grew, or your application got really successful and you have more QPS, more queries coming in that your one box Cloud SQL or even any MySQL system can offer. In that case, sort of Cloud Spanner is an obvious choice because you don't have to give up your wonderful SQL and relational semantics to be able to deal with the scale, which is what you would have had to do if you sort of chose a scalable solution, which was NoSQL. And so you can just take your Cloud SQL shards and then migrate over to Cloud Spanner, and then never have to worry about replatforming again. In terms of if you're starting out with a new greenfield application, again, if you expect to be growing very quickly in either in terms of dataset or app QPS or a combination, if you start with Cloud Spanner, you never have to replatform, right? So you have the ability to build a system once and then keep it growing and never have to worry about sort of maintenance and the hazards of, my box fell over because it ran out of memory and all those kinds of things. However, if you're comfortable with Cloud SQL and you don't think you need any of the high availability or management or scalability or relational semantics of Cloud Spanner, then if you're happy with Cloud SQL, you've already been building the applications on it, you don't expect the data set to grow or the QPS to grow, and as I said, you don't expect to be, you've already got all the maintenance pieces in place and management pieces in place, then by all means, if you're happy with Cloud SQL, please continue to use it. Next, can I explain how Cloud Spanner replicas work in the background? Does the Spanner use synchronous replication? Yes, it does use synchronous replication, and I have a few slides here that can basically walk us through this. But basically, as I mentioned, Cloud Spanner is synchronously replicated under the covers, so you will only ever have to deal with one database and one database endpoint. You never have to worry about which replica you need to talk to or rebalance over replicas, none of that, right? That's just completely hidden from you. You have to just worry about talking to your database. So we have a few slides here, as I said. Let's talk about the regional configuration first, because it's the simplest to talk about. So as you can see here, we've taken one regional Cloud Spanner instance, which has 3 replicas, as I mentioned earlier. These 3 replicas are in 3 different GCP zones within a given region. We've chosen a European region in this case, but it could be any GCP region. And as you can see, there are 3 read-write replicas of the database within this region. In the multi-region case, things get a little bit more complicated, but the original idea remains the same, which is that you have multiple replicas across multiple different GCP regions, across multiple different GCP zones within those regions. So we have 3 regions in the US in this particular configuration. This is one of the configurations we actually offer. It's our NAM EUR Asia 1 region, which is basically a global region, global configuration. So what that means is we have the write quorum in the US split across or spread across 3 different US GCP regions, and an Asia region with 2 Asia regions, each having read-only replicas, and then a European set, which has 2 replicas, both in different GCP regions. So what that means is we've basically distributed the data across different geographic locations to remove or reduce the probability of correlated faults due to natural or geographic issues. So as you can see here, there are 9 replicas spread across 7 different GCP regions. Now, what does that mean in terms of how you interact with Cloud Spanner? So you have one Cloud Spanner instance, which has all these replicas of the databases. In that instance, you can have more than one database if you want in an instance, right, depending on your use case. And each of these databases have multiple tables, right? And they go to multiple splits of the database. So what that means is Cloud Spanner is a sharded, synchronously replicated database, and each database has a full copy of the data across the multiple replicas, which means all the tables and all the data is stored in all the different regions fully, and the data is split across multiple what we call splits to allow it to spread over multiple different nodes, Cloud Spanner nodes, to again reduce the chances of a single failure bringing down the whole system, right? So we are parallelizing and splitting and sharding, all of which is happening automatically. So as we talked about, there are multiple zones, and if an update comes in, basically we use Paxos to replicate the data and get consensus into committing a write. So in this case, there's an update that comes in for table 1 and table 2. Let's say you want to do an insert across both tables. And then the Paxos protocol we have, which is, by the way, the protocol that we wrote ourselves, to optimize. It's not the open source Paxos protocol. We have our own optimized version of it to, again, give us the performance and high availability that we've talked about so much. So basically, an update comes in. We use Paxos to commit the write across all replicas. And by the time you get the acknowledgement back of the write, so if the commit succeeds, you are guaranteed that the data has been persisted, and you can query it as soon as you get the commit back. So let's move on to other questions here. Hopefully that helped, and I can go into it in more detail if folks are interested. So going back to our question set, is there a sorry, I lost my train of thought. Right. How does Cloud Spanner ensure that there isn't a single point of failure? So I think I covered some of this in our discussion so far, which is that Cloud Spanner is both replicated across multiple zones and multiple GCP regions. It's also sharded within a zone, right? So a zone is where a replica, a full copy of the Cloud Spanner database exists. And it's not one monolithic structure, right? It's sharded, and each shard is put on one of the multiple nodes that you assign for Cloud Spanner. So because of the sharding and because of the replication, we can guarantee that there isn't a single point of failure, right? Because even if one node goes down, which I'll get into a minute of what happens in case of failure, but even if one node goes down and there are multiple nodes, the other nodes are up and running to serve data. Now, I'm talking about one of the multiple zones, right? So in one zone, if you have 10 nodes and one goes down, then at most, that 1/10, at most, 1/10 the data is supposed to be unavailable. But because we are also replicated across zones, if the client notices that one node that it was talking to goes down, it will actually just contact the other regions with the same data. So from the client or the customer viewpoint, you actually don't even notice this. On top of which, we're constantly monitoring the health of our nodes and of the system overall, all different aspects of it. And so we're constantly rebalancing and resharding these nodes and the data on them, right? So in fact, the sort of failure scenario isn't really a huge deal because we're constantly already automatically changing the data set and where it resides and which nodes it sits on. So it's not a sort of one-time event where something happened and now you have a huge outage or a blip because the one or two nodes fell down, right? The whole thing is just sort of automatically managed for you. So you, as a Cloud Spanner user, don't even notice that there, in most cases, that one or two nodes went down. This is actually one of the reasons why we say that the SLA is offered for at least 3 nodes in an instance, because as you can see, if you have only one node and that node went down, then yes, your data is at risk, even though there are 2 other replicas that you can talk to. But in the case of 3 nodes that you get for a production instance, they're actually 3 times 3 in the regional case, so 9 nodes that can serve your data at any given point in time. So that and a bunch of other sort of optimizations that we've made, including the GCP network and the full GCP stack, allow us to have no single point of failure, because there are a bunch of virtualized components, all of which are sort of constantly rebalancing and healing. Moving on to our next question from the audience. When would I consider Spanner over BigTable? Great question. So Spanner is a relational database. I think that's the first thing you need to think about when you're choosing which sort of data storage system you need to use for your data set, right? Do you want a relational database with SQL, with schemas, with high availability, with cross sort of globally available distributed database, or do you not need that, right? BigTable is great for sort of the scalability aspect and for doing a bunch of high throughput reads and writes, such as like if you have time series data, et cetera. There's a lot of information on BigTable use cases. But the point is, it's not a SQL database, right? It's a NoSQL database. It's horizontally scalable and has a lot of great properties, but it doesn't offer you DDL or cross-row, cross-region asset transactions. It doesn't offer you SQL, and it doesn't offer you schemas with DDL statements. The next audience question: how many nodes can Spanner grow to? How many nodes can you buy? So Spanner is sort of, I don't want to use the word infinitely scalable, but it's designed to be scalable to, seriously, to petabytes of data and hundreds upon hundreds of nodes, right? So really the real question is, what is the capacity of the cluster or the data center that you're buying Spanner in, really, at some level, right? And how much money do you want to spend to buy Spanner nodes? But the technology inherently is meant to be scalable while providing asset transactions, which is what makes it so cool and why I'm so excited about it. And I can tell you from some of our internal use cases that scaling to petabytes of data and the associated sort of compute power required is really not a problem. Next question. I was wondering how long this will take to come up. Does Cloud Spanner break the CAP theorem? Absolutely not. So the CAP theorem is about maintaining availability in the face of partitions, right? And maintaining consistency in the face of partitions. And the way Cloud Spanner is able to achieve availability while having sort of partitions and achieve strong consistency in the face of partitions is because twofold. One, the entire stack is designed to have not a single point of failure, as we talked about, right? So it's got sharding, replication, synchronous replication and sharding built in. And we, again, use the Paxos protocol, which means that we don't have to, as long as we have a majority, we can continue to write. And as long as we have at least one replica available, we can actually continue to read for a long time. There's a really great paper written by Eric Brewer, who's the author of the CAP theorem, who's talked about sort of CAP theorem and Spanner and what that means, that I encourage anybody who's interested to go sort of read it. It describes all of these things in much more detail. It's on our website, cloud.google.com/spanner. And to round out that thought, so the other reason we can do this is because of Google's networking, right? So we have put a lot of thought and careful instrumentation of our networks to make sure that we can continue to operate across multiple types of network failures, and we have a bunch of redundancy and as I said, health checking and health monitoring built in to reroute traffic if we notice slowdown somewhere, or if we notice sort of some paths are blocked, then we can kind of reroute. All of this happening automatically, and the system sort of taking care of making sure that we can have availability of networks, right? So the Google networking as well as the Spanner stack both allow us to sort of push the limits of CAP theorem, as I talked about. But yes, as I said, there's a lot more detail in the CAP theorem and Spanner paper that I encourage you guys to read. Next question. How well does it perform over large physical geographies? Well is a very interesting term. So you can do ACID consistent transactions across rows, across regions, across data centers, across continents with Spanner, right? And you can do them with low latency so that you can run mission critical applications on Spanner. And some of it is to do with the fact that, as I mentioned, the Google networking is fabulous, and we can sort of, the Cloud Spanner calls basically the Cloud Spanner client puts any sort of incoming request onto the Google network as quickly as possible, so that it can be routed to the correct Cloud Spanner zone to be served, right? And there is intelligence built in so that we can choose the closest replica or get the fastest response, right? So in terms of performance, I think is where you're getting to here. And so let me talk about some of that. So basically, in the multi-region instance that we talked about earlier, that I showed a slide on, that we have US quorum and read replicas in Europe and Asia. The way to think about it is that for a multi-region Cloud Spanner instance, you're trading off write latency for read latency, right? So you want to have fast reads everywhere, and you can tolerate a little bit of slowness for writes in a particular region. So what that means, but by slowness, I'm not talking about seconds and minutes and none of that, right? Like what I'm talking about is, for example, if you have a write coming in from Asia in this multi-region configuration, then we expect, because of speed of light, which we haven't solved yet, or we don't go faster than the speed of light yet, a call from Asia will take sort of 300 milliseconds round trip time, right? 350 maybe. So there is that round trip time that you have to take into account for latency of a write that comes in from Asia for a US quorum. However, if you want to do a read from Asia, the Cloud Spanner client is smart enough to go to that replica that's closest to it in Asia for the type of read that you use, and give you a response. And within a region, we expect sort of 5-millisecond response depending on the type of reads that you have. Again, these are all very sort of hand-wavy numbers because it really depends on the type of read you're doing and the amount of data you're reading or writing, right? Like if you're writing 10 gigs of data, then it's going to take time, right? But the processing times for Spanner itself, we have tried to optimize this as much as possible. And we use, as I said, again, the Google network, which is highly optimized. So RTTs, round trip times, are much lower than what you would get in on the general internet, in terms of traffic. Hopefully that answered that question. Next question: how is Cloud Spanner managed apart from the Google console? Does it have a Cloud Shell or Cloud SDK? Yes, absolutely, absolutely. We offer the UI, obviously, Cloud Console. We have a gCloud SDK that has Cloud Spanner. All the commands are there for it. And we have a CLI. And of course, we have the API that you can code to directly if you so choose. In fact, some of our customers wanted to write libraries apart from the Silver languages that we had, or they wanted to sort of instrument it their own way, or wanted to use REST. So we offer gRPC-based client libraries that you can use, and that take care of a bunch of sort of maintenance tasks and things like that, like transaction retries, for example. And we offer a REST API as well, so that you can use it. If you have applications that must use REST, then you can code directly or write your own client library for the REST command as well. And all of this is, by the way, available on our documentation on our site. So you can, again, go to cloud.google.com/spanner/docs, and you should have a whole plethora of documentation there. Next question. Is it recommended to use cache engines like Memcached or Redis with Cloud Spanner, or is it not necessary? Great question. This is one of those things that depends. There are a lot of distributed systems answers that are it depends. So it depends on the kind of application you have and the latencies that it requires, right? So in most cases, Cloud Spanner's latencies are good enough where you can directly query the database itself. And of course, we cache hot data sets in memory, obviously. So a lot of that is taken care of by Cloud Spanner itself. But if you have sort of large data sets, or data sets that are sort of always being read, and you really like a gaming thing, if you have a gaming app and there's a bunch of users that are playing a game together and they all need to query some sort of game state that is not really changing that often, right? You need to flush it once in a while back to the back end, but mostly it needs to be served very fast, right? Like sub-millisecond or whatever. Then you can put a cache in front of your Cloud Spanner database, Memcached or Redis, if your choice, and then serve it from there. And then most of the QPS is kind of like handled by the cache. And once in a while, if there is some state change in the game, then you can flush it back to Spanner and then reload the cache, right? And all of that can, of course, because the database itself is mission critical, is low latency. You can expect that the cache refreshes don't take that long, and you can sort of cycle them based on your QPS cycles and things like that. Hope that answered that. Next question: what control do I have over how the database works? So again, this is sort of I can take this so many ways. You've set up your database with your schema, so there is that, right? You control how the schema works. In terms of introspection tooling, if that's what you're asking, we have a few introspection tools already, and there are a bunch more that are in the works that will be coming out later this year. But the first introspection tooling that we have is our query plan visualization that we have in the Cloud Console. So what you can do is you can run a SQL query, you can see how the query is performing, right? Whether there are table scans that you didn't expect, et cetera. Whether it's doing a back join with another table that you didn't expect. So you can look at the query plans and figure out, whether your query is performing the way you expected it to, and you can make adjustments based on that. As I said, there is a bunch of other tooling that's coming up. We have debug tokens that we will sort of release soon. We have, sort of a bunch of things to give you introspection into the database of how the queries are performing. In terms of in terms of the database itself, right, we offer sort of QPS metrics to see what the throughput of your database looks like. We offer sort of how many megabytes per second it's getting and how many QPS it's getting and responding with. We also obviously show you the CPU utilization of your database, because that's one of the key metrics that you need in order to figure out whether you want to add more nodes or not. We offer storage metrics, right? So all of these metrics are also available through Stackdriver, and we have a landing page for Stackdriver where you can see all of these metrics combined. And if you want to set alerts on any of these metrics, you can do so and see them on the Cloud Spanner console, right? So we're trying to offer you as much of an integrated solution as possible. Now, again, there are those who've been used to sort of tinkering with every aspect of the database. And for them, there is some control issue that you will have to give up, because it is a managed service. The whole point is you don't have to worry about how the database works. You just have to worry about sort of whether your database is looking like or performing the way you expect it to, right? Whether your schema is performing the way it's expected to, right? Whether you need to optimize your schema or not. I mean, the rest of it, you kind of have to sort of just let others deal with it, right? You never have to. Another way to think about it, right, is you never have to wake up at 3 in the morning from a pager because a node fell over, right? Or you're running out of storage capacity, right? We auto scale storage, for example, so you never have to worry about that, right? And the only thing you really need to sort of think about is what is your compute utilization, and do you need to increase compute depending on whether your new app has become really popular, so you add nodes, which, by the way, you go to the console, you change a number in a field, and voila, within a matter of seconds, you maybe 2 or 3 seconds, you get new nodes, right? And the same thing, you can actually reduce nodes as well just by changing a number. So the idea is you don't have to worry about managing or maintaining the database. The idea is you leave the worrying to us, leave the pagers to us, and you just have a happy running app on your database. Next, what happens in the event of a network failure? So I think we talked about this a lot. It depends on where the network failure is. If you're talking about network failure between Cloud Spanner zones or regions, then, as I said, in the regional case, you have 3 zones, which means if there's a network failure between from one of the zones to the others, then first of all, it's Google's problem to repair the network, not yours, right? Second of all, the other 2 replicas are up and running, as I talked about, right? So they can serve your data quite happily without worrying about the 3rd zone being down. And by the way, because there are a bunch of automatic things in place, and because we have a 24-hour SRE team that's managing and maintaining these Cloud Spanner instances and databases within them, somebody will be, I can guarantee you, somebody will be looking at this problem and trying to get the system back online as quick for that zone back online, because the rest of the zones are available, and to you, the Cloud Spanner instance and databases within it are available. But somebody's going to look at it and try to bring it back online. GCP and Google's philosophy actually is to do root cause analysis later, to get the system up and running, to fix the problem first, and then go and do debugging later, right? Sorry, root cause analysis later. So that's the one thing. In the multi-region case, multiply it out, right? There's so many more replicas that you can serve the data from that a single network failure, a single zone, single entire zone failure actually has almost no effect on you and your ability to serve data from Cloud Spanner. Hopefully that answered that. Next question. Can I dictate where my data is stored? So you can absolutely choose the Cloud Spanner configuration, and we put your database in the instance in which you've chosen it to be, which means within the configuration within which you've chosen to put your instance, right? So in the regional case, if you choose US Central 1 or EU West 1 or Asia East 1 for your Cloud Spanner instance, then your entire database, which means all your compute and all your storage, is stored within that region. In the multi-region case, right, depending again on the region configuration you choose. And by the way, we tell you which regions are going to be used in that multi-region configuration. So you are aware of which regions, which data centers essentially the data is in, which means which country or geography or city it's in. So you have that level of control. But no, you cannot pick. If you want to pick exactly which zone, exactly which cluster your data is in, then no, right? That defeats the point of having a managed database service, because you then have to worry about what happens if the zone goes down, or what happens if the storage is not available in that zone, right? So you don't have to worry about that. If a zone goes down, we move your data, let's say, to a different zone. What happens if any of those scenarios happen? We take care of that situation for you, and you just talk to one database endpoint and continue to function. Next question. How do I migrate from other relational databases? Great question. So right now, as I said, if you have a simple schema, it should be fairly simple to sort of take that schema and translate into a Cloud Spanner DDL language and into a Cloud Spanner schema, and then write data into it, right? I know it's a huge and manual process, and I totally understand that. We're working on various ways for our customers to make this easier for them. The first thing we're working on is sort of an import-export functionality that should be around in the next quarter or so, that allows you to take files in a GCS bucket and import them into Spanner, like Avro files, for example, that you can take a dump of your database, put them in Avro, put them in a GCS bucket, and then import them into Cloud Spanner, right? You can specify the schema, and then at least the data migration piece is taken care of for you. Over time, we also are working on simple push-button tooling so that, especially for, as I said, simple schemas that don't require too much sort of conflict resolution, you can just sort of do a simple migration path into Cloud Spanner. So we are definitely thinking about that and wanting to make this an easy solution for all of our customers. So please hang in there. And our last question, wow, we've run out of last question. What makes Cloud Spanner mission critical? So great question. The point of a mission critical database is that it's highly available, it's performant, and allows you to focus on delivering value to your customers without having to worry about database management, maintenance, availability, replication, and sort of brittle application code that will constantly break because the strong consistency and all those kinds of semantics are not being met, right? There aren't ACID transactions, et cetera. So Cloud Spanner gives you, and we've talked about a bunch of these things, right? Like Cloud Spanner gives you high performance, high availability, built-in replication, built-in security, so that you can run your absolutely sort of business critical applications on Spanner, right? Business critical is banks and healthcare and gaming and all of these sort of various scenarios in which your business depends on your data. We take that very seriously, right? We've been running Google's business critical data on Spanner for multiple years, and we are basically sort of with that experience saying that you can, with peace of mind, put your business critical data on Spanner, and then you don't have to worry about the database, its availability, and the ability to use it across multiple regions, geographies, and continents. So with that, I think we're out of time. If there are any more questions, I'm happy to answer them sort of on the platform. But I hope you enjoyed this session, and I hope some of the questions were answered. I have to say I wasn't stumped so far, but they were really good questions. So maybe we'll do this again. But stay tuned in the meantime for the next session, coming to you live from Google New York office in a bit. Thank you.